Namaste. हमेशा खुश रहो बिटिया. I am JVWU Dr. Lily Trivedi, and today I am going to take the lecture of BSCBED 4th semester ZBC Faculty of Education and Methodology, and the course is Anatomy, Ecology and Evolution, and the session today is Morphological, Anatomical and Physiological Adaptations of Xerophytes. Now, let's start. What are xerophytes? Now, if we come to xerophytes, we find that they are plants having succulent. Now, see, some of them are succulent xerophytes and they have fleshy leaves. Now, fleshy leaves, this is calicho, this is biofilm, this is aloe vera, agave, etc. So, now when we have these leaves, now what happens here? Xerophyte means extreme conditions which are having high temperature and high dry winds. So for this, the morphological adaptations that are, the root system is very well developed. Why? Because there is no water. In xerophytic areas, there is a lack of water. So root system is very well developed with root hairs and root caps. The roots are fasciculated. That means they are in number, they are not taproot. They can also be, they are having number of branches. The stem are stunted, woody, dry, hard ridged and covered with thick bark and may be underground. For example, some of the stem are underground, and whatever the phylloclade, the stem, like in sacrum, it is covered, and opuntia. So opuntia has a phylloclade which is covered with spines. The stem can be covered, is covered with thick coating of wax, and silica also indents here in some plants. Like Calotropis has dense hairs and Equisetum has silica and there is wax. Now stems may be modified into thorns. So we have asparagus, we have thorns in ulix, and it can also be modified into cladode. Leaves are very much reduced and small scale-like and appearing for only brief period. They can be sometimes modified into spines or scales. Now the lamina may be narrow or needle-like it is in Pinus and divided into leaflets as in Acacia or aloe. Now what happens? So these are the morphological adaptations. Now what are the adaptations which are anatomical? The root hair and root caps are very well developed. Now roots become fleshy to store water like we have in the asparagus. Now since water is to be stored, the water storage region is the thin-walled parenchyma cells. Now we have the cuticle is very well developed in and a very well developed epidermis with thickened cell wall. There is several layered skeleton chymatous hypodermis. Now if you ask the reason why, because we have to prevent the water loss, so there is thick cuticle in the non-succulent xerophytes, and skeleton chymatous because it needs tissue to keep the standing. Stomata is sunken. Why? Again, the reason is to prevent water loss. And well-developed vascular and mechanical tissue is present. Now, their leaves also show well-developed cuticle. And there are bulliform cells present in the Poaceae family members or Gramineae family members like in sugarcane. The mesophyll is well developed with vascular and mechanical tissues. Now, as for concern for the psychological adaptations, what happens? The stomata of these plants will open during night hours and will remain closed during the day. Now this is an unusual feature and it is also associated with the metabolic activities of these plants. So we have in xerophytes, the chemical compounds of sap are converted into wall-forming compounds, mostly like cellulose and fibrin. Now enzymes are more active in xerophytes, and the capacity of xerophytes to survive in long drought is due to the resistance of hardened protoplasm and desiccation. The xerophytes have high osmotic pressure, which gives the turgidity to the cell sap. So you see, as the xerophytes are now in this, and we have in the anatomy, latex is also present in xerophytes. The parenchyma is already said is very thick walled, and hairs are present in xerophytic cells. What hairs are present, which are especially in the alpine region, because they cover the epidermal cells to prevent loss of water due to the strong winds, and they are abundant on the upper part and the matting of hair also prevents the rapid evaporation of water through stomata. Now, as already discussed, stomata is sunken, and they are found in the depressions on leaf surface of some plants. Now, there is another factor, rolling of leaves. In many xerophytic grasses, the rolling of leaves is there. In these grasses, the stomata are conformed to the ventral surface of the leaf only, so that when the leaf edges roll inward, the stomata is effectively shut away from the outside stem. So this is found, and this air enclosed in the rolled leaf soon becomes saturated with water, and outward water diffusion stops. Now special motor cells are present on the upper surface of leaves for this stomatal rolling. So these are the motor cells present in xerophytic grasses. They are responsible for the rolling of leaves. Now in fleshy xerophytes, what is present? Special water storage tissue is present, and mucilage is also present in them. So we have, and these xerophytes which have fleshy leaves or stems are known as melacophilous. And latex tubes are present, in which the viscosity of the latex, the transpiration is also reduced to some extent. Now there are several species in xerophytic plants like euphorbia. Then many cacti are there, cactus plants like opuntia, cirrus, peristia, agave, aloe, caparis, calotropis procera, catharanthus, argemone mexicana, and miriam, casuarina, banksia, erica, etc. are the xerophytic plants. So students, I hope you are satisfied with my digital session, and if you have any query, please give in the comment box. I will resolve it soon. This digital session was powered by the 2.0 version of Jyoti Vidyapeeth Women's University. Thank you and namaste, and the next lecture will include the adaptations of halophytes. Thank you very much. Namaste.